Hey everyone. So we are going to be moving on to finding the areas and sometimes perimeters of some weird looking shapes. So I thought we'd make a quick cheat sheet to review what we know about finding area and perimeter or circumference for circles of some shapes that we have so we can reference it in the future. So I'm going to have a picture of this sheet posted onto the classroom next to this video, so you can just print it out or copy it down at your leisure or use it on your computer if you want. And I'll also have some quick examples that we'll go through now posted too. So our first shape is a rectangle. You know it's a rectangle because it has four sides, there are right angles in the corners, and the two opposite sides are congruent to each other, the pairs of opposite sides. So to find the area and perimeter of one of these magical shapes, you need to know two measurements. You need to know the length of the rectangle. So there's my fancy L. I don't know why it has to be fancy, it is. And you need to know the width. And then we know that the opposite sides will be the same as the others. The area for a rectangle, the space inside that is measured in square units, can be found by taking length times width. And our perimeter, which is the measurement of the outside, just measured in straight old units, is when you add up all those sides. So the perimeter would be the length plus the width plus the length plus the width again. Or you could combine like terms there. The perimeter is 2 lengths plus 2 widths. So let's see a quick example of that. So here's a rectangle. It has a length of 5 and a width of 2. So to find its area, I would multiply length times width. So 5 times 2, and I would get 10. And so since my unit was inches, I would measure in squinches, square inches. As for the perimeter, I like to just fill in all the other sides as well. So this one would be 5 and that one would be 2 because they're the same as the opposite side. And I'd add them all up. So my perimeter is going to be 5 plus 2, 7 plus 5, 12 plus 2, 14. And since my perimeter is just measuring these lines along the outside, it would just be in straight old inches. Back to our cheat sheet for triangles. Slightly trickier, but we got it. So with triangles, there are different types of triangles. With rectangles, it's just how big is it, but with triangles, they can be different shapes because they have different angle measures. So the two we're gonna just focus on are, is my triangle a right triangle, meaning there's a right angle, or is my triangle not a right triangle? We're just thinking about those two categories. The reason why this matters is because with triangles, the formula has to do with two measurements, the base and the height. So on a right triangle, my base, or B, is down on the bottom, and my height is here on the side. And they're both sides of my triangle. So they're typically really easy to see, and you'll actually see they are the two that would form the right angle if you're in a right triangle. In a not right triangle, the base is the same, it's still the bottom, but the height is not actually one of the sides because you would never measure how tall something is from top to bottom on a slant. You'd always try and measure as straight down as you could, top to bottom. So our height of our triangle actually is if we dropped a right angle, the altitude, the height, down to make a right angle with the base. That's how tall the triangle is. So we call that height. So if you're with a right triangle or a not right triangle, you need to know those two measurements. It's just where they're located. Where is that height? Is it inside the middle of the triangle or is it one of the sides? So the area formula for a triangle, either type, is half the base times the height. Just using B and H for simplification. For perimeter of the triangle, you would add up the sides. You could come up with some sort of formula here, but if you're given all the sides of the triangle, then you'd add them all up. At this point in your schooling, you probably won't be asked to find the perimeter of a lot of triangles unless they give you all of the sides possible. So we probably are just going to be focusing on area when we're thinking about triangles, but the perimeter would work adding the sides up. So let's do some examples. So for my triangles, I have two triangles. One is a right triangle, and that means there's a right angle in it, and the height is on the side of the triangle. And the other is a not right triangle, and the height is not one of the sides. It's actually from the top tip of the triangle down to the base. So we'll find their areas. So in this case, I would take my formula, area equals half of the base times the height. And I'd fill it in. So the half isn't a measurement here, but I need half of my base, which is 4, times my height, which is 9. And you can do this in your head, or you could type this into a calculator, but I would do it like this. 4 times 9 is 36, and half of that is 18. And then I would think about my units. So I'm measuring in centimeters, but since it's area, it would be squenimeters. And it would be talking about how many little centimeter by centimeter squares could I fill up that triangle with. And it would take 18. In our second example, the formula is the same. Area is half the base times the height. So I fill it in. Area is half the base, which is 7, times the height. From the toppest tip to the base is always your height, so that's going to be 5. And then you mark it inside that triangle. And so then I would do my calculation again. Here's another way you could write that multiplication. So 7 times 5 is 35, and half of 35 is 17.5. And I look at my unit, it's meters. And since I'm measuring area, it's squared meters. Our last shape we're gonna look at, before we get to that, neither of these triangles I can find the perimeter for. It's not possible for 7th graders. It's possible in the future. But it takes math that you don't know how to do yet. So because I don't know how long the third side of this triangle is, or these two sides of that triangle, it's not possible for me to come up with a perimeter, so I'm not gonna worry about it. One day, you'll learn. Our last shape we're gonna look at. So our last shape is circles. So we just spent a long time talking about circles, and hopefully you remember our formulas for area and circumference. Circumference is basically the perimeter of a circle, except perimeter is always add up the sides, but circles don't have a side. So that's why we don't call it perimeter. We call it circumference because it's special. When I'm thinking about circles, the thing I want to know, the thing that defines both the area and the circumference is the radius. And so that gives us our formula for area. Area equals pi times the radius squared. And then special little side note here, r squared is r times r. Our circumference formula is circumference equals 2 pi r. All right, let's use these formulas for one quick example. So, say the circle I was trying to find the area and circumference for had a radius of 6 feet. I would plug that in for radius, so area equals pi times radius squared. And I'd fill that 6 into my radius here. So pi times 6 squared. And I would do 6 squared is 6 times 6, which is 36. So my answer could be 36 pi for my exact answer. Or I could type 36 pi in my calculator, 36 pi, and I get 113.1. And that would be in square feet for either answer. We talked about how both of those are fine. One is an exact answer because it includes pi, and one is rounded because I had to round. And I chose to 1 decimal place. For circles, we don't find perimeter, we find circumference. And that formula is C equals 2 pi r. And so again, I use my radius and fill it in. So I'm going to be finding 2 pi times 6. I could leave it as my exact answer of 12 pi. Or I could calculate 12 pi in my calculator, 12 pi. And I get 37.7. And I think about my unit, well, circumference, we've even seen this happen. You could snip the circumference and lay it out flat against a ruler like we did with that string. So I know that since it can be laid next to a ruler, I can measure it in straight up feet. And so there we go. There's our cheat sheet. We're gonna be using this for our next project and for the work you're gonna do this week. So find a way to make yourself a copy of this.